Okay, in this video we're going to have a look at neutralization. But before we do that, let's have a quick recap of a couple of terms. We've got our pH scale going from 1 to 14, and one end is acids. pH 7 in the middle was neutral, and the opposite end we had our bases. We should remind ourselves that an alkali, because we use that word in our next little topic, is a base, so the same as a base, but the base is soluble. So an alkali is a soluble base, okay? So base is soluble, and therefore we have an alkali. Also worth reminding ourselves that acids, all acids contain hydrogen ions, so H plus ions. We'll look at some examples of that to remind ourselves in a moment. And these alkalis that we've spoke about, they contain hydroxide ions. And again, we'll have a look at some examples of that in a second. So that's our little recap, just to remind us some key points. Let's look here, which is a copy of the workbook that I have shared with you at the topic of neutralization. And the first thing I'm asking you to do here is to calculate or work out the formulas for each of these chemicals using the rules around valency to do this. Now, to help, you notice that I've put in here the charges on the ions to help with this. So I'm going to do one just to show you how this works. I'm going to pick on nitric acid, and I'm going to bring my working out page over to allow me to do this, okay? So nitric acid, it tells you on there that a hydrogen ion is H+, and in nitric acid it is joining with a nitrate ion, which is NO3-. The charge tells you how many bonds this wants to make. So this is a +1 ion, it wants to make 1 bond. This is a -1 ion, so 1 bond. Cross these over, therefore I need 1 lot of hydrogen, and then the NO3, I need 1 lot of NO3 in order to make the formula work. If you're not sure about this method, there's a video on the channel called Finding Formulas. Have a watch of that, and then that will refresh you of that process. So in here, my response to this would be HNO3 would be the formula. And when you do this, you will find out that all these acids have in common is they are going to contain a H+ ion. Okay, because hydrochloric acid will work out as HCl, and if you check this one, this will come out as H2SO4. Okay, so they all contain hydrogen ions in there. Remember, they have to dissociate in order to release the ion, but that's what they will do. This side of the table here, we've got alkalis. We'll have a quick look at those. Let's do one of these in the same way. So let's pick on, one that's a bit more challenging. I'm going to pick magnesium hydroxide, which contains magnesium ions, which it tells you on your sheet is 2+, and a hydroxide ion, which is a single negative charge. The fact it's 2+ means it's looking to make 2 bonds. The fact it's just a -1 means it's wanting to make 1 bond. Cross these over, the magnesium gets a number 1, we don't need to write that down, but the hydroxide, now be careful, gets a number 2. So I'm going to put that in brackets because I need 2 lots of that in order to make the formula work for magnesium hydroxide. If I come back to my table, sodium hydroxide, you should work out that this is NaOH, magnesium oxide we've just done, it's there. And calcium hydroxide follows a similar pattern in that we need 2 hydroxides in order to make it work. Notice they all contain hydroxide ions. Okay, they all contain hydroxide ions in there, and that's what makes them the alkalis that we need to be talking about. I'm going to pause the video there. We're going to talk in the next one about the neutralization bit, so it can help you with that work as well. So watch this in parts, complete the bits as you go. Good luck everyone, hope it makes sense. Okay, in this video we're going to continue the work on neutralization, and I'm just going to talk to you about what this means and the general equation for this, okay? So if we mix the right amount of acid with the right amount of alkali or base, then we will carry out a neutralization reaction, and this will produce a salt and water. These will be neutral, that's why I've done them in green. So we've got neutral things here, pH scale for for neutral substances is green. Acids we know are red on the pH scale, and alkalis are blue. So we take an acid alkali, we make a salt and water. Okay, and these have to mix in the right amounts in order for this to work. Let me give you some key points to remember here, because the salt is the tricky bit. How do we name the salt in this reaction? So in your notes, and we've got a box here that says the general equation is, and that's what we've got here. That is the general equation. An acid and alkali makes a salt and water. Underneath here, we've then got how to name the salts. Okay, so we've got different types of alkalis or bases that we can use. We can have metal oxide. So for example, sodium oxide is a metal oxide. We've got metal hydroxides. There's the example of magnesium hydroxide. Or we could have metal carbonates, and there's the example of calcium carbonate. Each of these will react with an acid in the right amount to do a neutralization reaction. The metal part of these gives the salt its first name. So that if it was sodium oxide being used, the first name of the salt would be a sodium salt. Magnesium gives a magnesium salt. Calcium carbonate gives a calcium salt. The second name of the salt comes from the acid we use. So if we use hydrochloric acid, we get chloride salts. If we use sulfuric acid, we get a sulfate salt. And if we use a nitric acid, then the type of salt we get is a nitrate salt. Probably best to illustrate this with an example to help you to understand this. Here is the example that I've got for you. I've just written it out on my sheet here just to help us visually get a better understanding of this. And what you can see here is we're taking hydrochloric acid, reacting it with sodium hydroxide. Now I said to you that the salt that's going to form, the first name comes from the metal in the alkali here. So the first name of my salt is going to be sodium. The second name of my salt comes from the acid, and because it's hydrochloric acid, then this will form a chloride salt. So there's my chloride salt, and product with that will be water. They always produce water. Okay. Had this been sulfuric acid, this would then be sodium sulfate. If it was nitric acid, it would be sodium nitrate. If this was magnesium hydroxide, say, then this would be magnesium chloride. So you can see how the names of the salts are going to change. I've done this first example. You can write this in. You can have a go also at the balanced symbol equation for this. And then if you go back to your workbook, you can see here there are 3 more of these for you to try. What I'll do at the very end of the video is put the answers to all these with the balanced equations on, so you can check your work and make sure that your work is correct. Okay, hopefully the final little video giving you instructions on neutralization. There is one to watch out for, and that is if your base is a carbonate, then the general equation that we have changes. So if you get an acid and a carbonate, you still get the salt, you still get water, but what you get as new now is carbon dioxide. So the carbonate will produce carbon dioxide. So watch out for these. If you get one of these, we add in carbon dioxide as well as the salt and water. One of the questions here asks you, how do we prove that carbon dioxide is formed? We have done this test before, but carbon dioxide, you collect the gas, you bubble it through lime water, and the lime water will go cloudy, proving that the gas is carbon dioxide. What I want you to do with this is, underneath here are some questions for you to try. Writing the word equation initially and then the balanced chemical equation. If you have a go at those, I will then put the answers on at the end of the video for you to check and make sure that you have got it correct. Okay, good luck everyone. Bye bye. Okay, here are the answers to the neutralisation questions. Please make sure you've had a go at these before you go through them. And if you are struggling with the formulas, I'll put a second video into the Google Drive classroom for you so that you can access it and look at how to work out formulas. Okay, so answers. Sulfuric acid with magnesium oxide. The salt is going to be magnesium and then sulfate because of the sulfuric acid. We always get water. Here we have the balanced chemical equation. So H2SO4, MgO, magnesium sulfate is MgSO4, and water is H2O. Next one down, we've got nitric acid with lithium hydroxide. So the salt is going to be lithium nitrate because of the combination of these two. And then water. Nitric acid is HNO3, lithium hydroxide is LiOH, and then lithium nitrate is LiNO3 with water again on the end. And again, that equation is a balanced equation. And then the bottom one here is hydrochloric acid with magnesium hydroxide. So these two come together to make magnesium chloride, releasing and water, sorry. Formulas, 2 lots of this because we need to balance it in this way. Magnesium hydroxide, be careful here, the brackets indicate that we need 2 lots of hydroxide with the Mg2 plus ion. Magnesium chloride, MgCl2, notice again, and then water. And then I said earlier, the balancing, 2 here and a 2 here, make this balanced. I'll actually put a second video in on balancing equations. If you're struggling with these, it's an opportunity to practice the balancing equations, okay? That's the answers to the first little bit. Second part, we're looking at reactions of carbonates. Now remember, with a carbonate, you end up with a salt, but you get carbon dioxide as well, and you get water. So we have a third product in these reactions. Here's the answers. So hydrochloric acid with calcium carbonate, we're going to get calcium chloride is going to be the salt with carbon dioxide and water. Here's the formulas. Remember, carbonate ions are CO3 2-. If you're working these out, the formula for carbonate ion is CO3 2-. There's my equation. That's actually balanced by putting a 2 in front here. Nitric acid and lithium carbonate, these two come together, you're going to get lithium and then nitrate as the salt with carbon dioxide and water. Again, I've put the formulas in, and to balance this, we need a 2 here and a 2 here. Okay, and the final one is sulfuric acid with magnesium carbonate. Magnesium sulfate will be the salt, carbon dioxide and water. Again, here's the formulas. It's already balanced this equation to do this. Please make sure you can tick these if you got them right. If you're struggling with naming the salts, go back and watch the little video on naming salts. If you're struggling with working out the formulas, watch the separate video on working out formulas. And if you're struggling on how to balance equations, then please watch the video I'll put in there as well on balancing equations to help you with that. Good luck, everyone. Enjoy. Take care.